Hi and welcome to this chapter on NACLs. So NACL is nothing but a network access control list. The network access control list acts like a firewall to control access to and from your subnets. So a perfect example of this is that suppose you start getting abnormal traffic from a set of IP instances. You can actually block traffic from these IP instances. So this is a common use case of a DDoS attack. So if you're getting a lot of traffic from one set and this particular IP addresses has been identified by your IT security team, you can actually put a deny rule in your network access control list to ensure that all traffic from these IPs is denied in your subnet. A subnet comes with a default network ACL. This allows all incoming and outgoing traffic by default. You can create custom network ACLs. One common thing to note about NACLs is that they are stateless. So if traffic is allowed inbound, it is not necessary that the same traffic will be allowed in the outbound case. So let's say you have a request on port 80 to your web server. Now even if the traffic inbound is allowed and the request comes to the web server, if the web server needs to send a response back outside on the same port, if you don't allow the outbound rule or the outbound port, the web server will not be able to send a response back to the client. As an example, we have EC2 instances which is defined in the subnet. Let's say it's attached to the internet gateway, and then we have our NACL rules which is defined for each subnet. So just remember that NACL rules are defined at a subnet level. Here an example of how the rules look like for a network access control list. So you first have the rule number, the type of rule, the protocol, the port range, the source, and what is the action, allow or deny. This is similar to any firewall type of rules. So anyone who's familiar with firewalls, all these parameters will seem pretty familiar. So in the first table, we are allowing all traffic on all protocols and all port ranges from any source. This is allowed to the network. So the first rule number, which is rule number 100, in the first table allows all traffic. Now you can also see another rule number, which is star, which denies all traffic. These are the default two rules which come in a network access control list. Now, one very important thing is that when AWS goes through the table, if a matching rule is found, then it discards all other rules. Secondly, each rule is applied according to the rule number from lowest to highest. Now, in the first table, as an example, AWS finds the first rule, which is rule number 100. It sees allowing all traffic on all protocols and all port ranges. Since this is a matching rule for all traffic, it then discards the second rule, which is to deny all traffic. Let's look at another example by looking at our second table. So our second table in rule number 100 defines the type of protocol, which is TCP, on all port ranges, but from a particular source IP, that's 192.154.1.10. So this IP will be allowed to communicate with our subnet on the TCP protocol on all port ranges. Next, we have a deny rule. The deny rule is 101. So remember, the rules are looked on as from the lowest to the highest. So rule 101 says that all other traffic will be denied. Now the third rule is 102, which says let's allow traffic from 192.154.1.11. So let's say an IP of say 192.154.1.11 tries to access our subnet. What's going to happen? The traffic will be denied. So even though we have an allow rule, since it is after the deny rule which matches the traffic coming from that IP, the traffic will automatically be denied. So the only IP which will have access to our subnet will be 192.154.1.10. It's important just to understand how to define rules and how these rules work. This is from an AWS developer exam perspective. Obviously, when you do become a professional, you should play around with subnets and network access control lists to understand better how to deny certain IPs from entering your subnets. Let's now go on to the console and see how to manage network access control lists. So here I am in my console. Now for this I need to go on to my VPC. So again I go on to networking and content delivery. Now we only have a default VPC. So let's go to our default VPC and you can actually go on to your subnets. So now in our default VPC, we know that we have 3 subnets for the 3 availability zones. Let's click on any of the subnets. You will see one section for network ACL. So in the network ACL, I did mention that we have the default rules of 100 and star. We have 2 types of rules. One is basically for the inbound, that's all the traffic coming into the subnet. And another is for the outbound, which is all the traffic going out of the subnet. So you can edit both types of rules. By default, all the traffic from all sources are both allowed in and out of the subnet. You can change this accordingly. Now, in order to change your network access control list, what you can do is that you can go down and go to network ACLs. You can go to the ACL which is attached to all your 3 subnets. So you can have a different NACL per subnet. Click on edit and then add rules as required. So if you want to have a rule which will probably bypass rule number 100, then put the rule number as 95. You can put whatever protocol you want. And you can put the port ranges, source, and the allow and deny as required. So here is where you can actually change the network ACL. Once you make the change here, it will be automatically applied to your subnets. So this is how you can actually manage network access control lists from AWS. Let's now move on to the next chapter.